guys, welcome back to my channel. Today's topic is conjugated systems and effects like inductive and mesomeric. But first I'll do the homework from the last two videos. The first one was drawing the orbital diagram for oxygen. Oxygen has 8 electrons, so if you remember the orbital diagram, we need to have 8 electrons, right? So we have 1s2, 2s2, that's 2 and 2, 4. You need 4 more, so 2p, 4. The maximum that can go in P is 6, but we only need 4. So 2 plus 2 plus 4 is 8. Now draw the orbital diagram. The 1s2 will have 2 electrons in opposite directions. The 2s2 has 2, and then P has only 4. You have to fill each one individually and then fill the first small box. And that is the answer. The second question was drawing the molecular orbital theory diagram for boron. Now boron, one atom, has 5 electrons. So molecular means a molecule of boron, which means 2 atoms of boron, which means 10 electrons. So first draw the orbital diagram. So 1s2, 2s2, that becomes 4, and you need only 1 more electron to make it 5, so 2p1. Okay, so now draw the basic structure for the molecular orbital diagram. So draw the one for the s, then draw the one for the 2s, and then finally draw the one for the p's. Then you will label them. So sigma 1s2, 2s2, 2p1, then sigma, sigma antibonding, sigma, sigma antibonding, pi, sigma, and then the antibonding. Then we will fill these, just like we did in the orbital diagram. We'll do the same for the molecular. First, always fill the bonding shells and then go to the top ones, which are the antibonding shells. In this last P1, we have only 2 electrons, so we first have to fill the bonding shells, and pi has lesser energy than sigma, so we have to fill pi first. So we fill each shell with 1 electron. You have to share it individually between both the pi's. So that shows the answer to A, which is drawing the orbital diagram. The second is writing the electronic configuration. So we have sigma 1s2, sigma antibonding 1s2, sigma 2s2, sigma antibonding 2s2. Then you have pi 2p2. The third one is finding the bond order. So bond order is bonding minus antibonding divided by 2. So bonding, you can see that we have 2, 4, and then 6. So 6 minus, check the antibonding on the top, we only have 4 electrons, right? 2 from S and 1s and 2 from 2s. So 6 minus 4 is 2, divided by 2 is 1. Our bond order is 1. And the last D part is whether it is paramagnetic or diamagnetic. Now, the last shell that you filled, you can see that it has only 1 electron. It is unpaired. So 1 electron means paramagnetic. If it was 2, it would be diamagnetic. So here we have paramagnetic. This is from my last video. So it was a calculation question. We were given the moles of, I think it was sodium nitrate, and it was 4.47 times 10 to the power minus 3 moles. And then we were also given the volume of the solution, which was 50 milliliters, which is equal to 0.05 liters. And you are asked to find the molarity. Now the formula was molarity is equal to the number of moles divided by the volume of the solution in liters. So you've got both the values. Just divide the first one by the second one, and you will get 4.47 times 10 to the power minus 3 divided by 0.05, and your answer will be 0.089. The next question is the color of the solution of copper sulfate. Now, sulfate gives a white precipitate. I told you that, but I also told you that copper itself in the +2 form will give you a blue colored a solid or solution. Now the cation will dominate, and hence the solution will be blue in color. And the last question for the homework was another calculation. You were given the value of sodium hydroxide, the normality, which was 0.102, and you were given the volume, which was 9.34 milliliters. You are also given the volume of the HCl that it was titrated with. It was 10 milliliters, and you were asked to find the normality. Now, the formula that we know, which connects all these numbers together, is N1V1 is equal to N2V2. We have all the values except for N1. So N1 times 10, which is the 1 is for the HCl, is equal to the N1V2, which is for the NaOH, which is 0.102 times 9.34. When you arrange it, you will get 0.095 normality. Okay, now we'll start with today's topic, which is conjugated systems. The definition is alternating double bonds, or to make it easier, you can say a double bond separated by single bonds, or a double bond between two single bonds. For example, in this case, you see a double bond, then a single bond, then a double bond, then a single bond, then again a double bond and a single bond. So this is conjugated. To make it easier, I make it a yes or no system. So you can see yes, no, yes, no, yes, and then no. The yes is a double bond, the no is a single bond. But in this structure, you can see yes, no, no, and then a yes, right? So this part is not correct, and hence it is not conjugated. Now, something about a conjugated system. For example, here we have benzene, which is a very common structure. You need to know how to draw it. It's a cyclic structure, and it's got 3 double bonds. It is conjugated, right? So because we have yes, no, and a yes, and a no. So these double bonds, they impart some double bond character, some pi character to their neighboring single bonds. And this causes it to have a mesomeric effect. This causes it to have a resonance effect. The mesomeric and resonance are the same. And this is also called a delocalized structure, because the electrons from the double bonds are being delocalized into the rest of the structure. So the whole structure kind of has like a double bond character. Now we have 2 types of effects. They're called inductive effects and mesomeric effects. Inductive effects are for single bonds, for sigma bonds, and mesomeric is for double bonds and pi bonds, as we just mentioned with benzene. So each of them have a positive and a negative. So we have inductive positive and inductive negative, the same way we have mesomeric positive and mesomeric negative. Mesomeric is also called resonating effect. So the inductive and mesomeric negatives, because they're negative, you can take it as electron withdrawing. Because they withdraw electrons, they become negative, right? And inductive positive and mesomeric positive, on the other hand, an electron donating or electron releasing ones. Because they let go of electrons, they become positive themselves. Now in the exam, you will be given structures and compounds, and you have to say whether they're inductive positive, negative, mesomeric, or positive or negative. This is something that you need to know of heart. The point is that there are some functional groups that push electrons away, and those are electron releasing, and there are some functional groups that pull electrons towards themselves, and they are the withdrawing ones. So one thing that might help you is that inductive positive is very we only have a few structures, and they are all alkyls, which is CH3 compounds without functional groups. They're all inductive positive. The rest are all inductive negative. You can see the inductive positive are all the CH groups, anions and alkyl groups. And the negative inductive group are everything else, like halides, fluorine, chlorine, or like ethers, or esters, or amine groups, amides, nitrate, cyanide, ammonia, everything else. With regards to resonance effect, which is mesomeric effect, the positive mesomeric is more than the negative. So the positive, you have the halogens, the hydroxides, the esters, the amines, but for the negative, you only have carboxylic acid, aldehydes, the double O bonds, for example. Then you have cyanide, and yeah. Now moving on to the homework for today, just 2 questions. The first one is, State which one of the following is not conjugated. Is it A, is it B, or is it C? And then the second question is the phenyl group M positive, I positive, M negative, or E positive? And that would be it for this video. Hope you enjoyed it. See you in the next one. Bye.